Welcome to Industrial Applications Level 2. This video is called Not Using Branches/Jumpers, otherwise known as Part 8, No Jumpers Allowed. In an earlier video, we talked about branches and jumpering. And when we were talking about that, we ran into a situation that I talked about where if I edit a rung and put a branch around this contact, that contact has no control now. In fact, that output is completely out of the equation in so much as the turn-off is concerned. That can lead to some unpredictable and dangerous situations because, again, as electricians, as PLC programmers, we focus on that word control. Jumpering out a contact of any description takes that control element away. Now, there are ways that you can negate bits that you don't want to use for a particular reason for a test, or you might want to put a placeholder that actually can function, and a knob is not going to work for you there. So what you can do is you can create a couple of rungs of logic that will really help you out. So these are not regular programming. These are like I'm developing my program, or the machine's down, I just have to get it to finish one cycle kind of solutions. These are not permanent solutions. These are fixes that I have discovered over the years that do help out. So the first one is I'm going to have a rung here, and I'm simply going to place an output on it. There's no preconditions. That being the case, when the PLC is on, this internal coil is going to be true. And I'm going to go to variable selector, and I've already created this for demonstration purposes to shorten the length of this video. I've created one called jumper. Sometime when I find it, let's go here. It's not a bool, it's a dent. There it is. And I'm going to just select bit 0. And you'll notice I've aliased it for the whole, anything that says jumper is got a troubleshooting bit. And what that does, because this is always on, I'm going to go back to, let's see, I'll go to my conveyor. And here, if my program 2, I don't want it to run, then I simply put the not jumper 0 bit, the troubleshooting bit, ahead of it. That's always going to be false because I'm asking to check, is it off right now? If it is, I'm good. It's on, okay, I'm no good, it's not going to work. And that's what I want. This has now effectively blocked that out. Now there are situations that can occur where you have an ambiguous state, and using NOT logic, which we'll cover in another video, will really help out. But in this case, this is acting to block this. We have not removed it from the rung, and here is the real power of using something like this. I'm not saying you have to use this, I'm simply saying something like this. I am not defeating anything other than this one contact, so I only end up having 2 different program run selections. This one is effectively nulled out. Now I could delete it, but later on I come back, I want to reinstate it. I have to remember where it is, I have to have careful notes. Nobody, we can see up here, has got no comments. So this is where the power comes in. I'm going to go to a different program. And what I'm going to do is I'm going to go to my variables. So I'm going to go to variable monitor, or variable select, and I'm going to type in jumper. Nope, the one oven door. I want the micro because it's global. Jumper. Okay, let's find that, and then I'm going to click on this and right click it, and you see the bottom it says cross-reference browser. That's what I'm looking for. So I'm going to right click it on the DINT level, and the cross-reference browser takes a complete poll of all of the logic and looks for any occurrences of that particular variable. And what we find is it has discovered it in two places, and it's in the bit 0 is in program 1, which is our last program that I created, and it has a write access, which means I'm writing to it, I'm turning it on or off. And it's also found in my conveyor. So if I go to this, I double click on the first one, it's going to show me the wrong, and it goes, oh, this is a troubleshooting bit. And if I was a conscientious, hardworking, programmer, okay, this rung sets up test bits for logic trials only. So if you're a person who's not really sure what's going on, you see that, oh, okay, I better call somebody who knows what they're doing. Or if you're not, you go, oh, okay, great. And you see that and you go, oh, that's a bool. You'd right click and you'd find from here, the bottom, that it was actually a DINT. So let's go to the second rung. And when we jump to it, it goes right to it, and we've got it not. When we saw in the other program, this was unconditional, so that's on all the time. So, oh, so somebody's blocked program 2 out. And it could be that they're not running it. Now let's say that it's not a troubleshooting bit, but we still want to disable program 2 from running. Well, there's a simple solution for that. First of all, we're going to use variable selector. Only now what we're going to do, let's go to our conveyor, and we're looking for run program. So let's just try typing that in because it's not popping up. Run, oh, prog 2, okay, PROG. Okay, it is a bool. Okay, that's good. And we're going to go OK. Now here's confusing logic. So you have the not and the true in series. They just cancel each other out. Moreover, though, it's not a dead short because no current can flow, because at no time will both those be satisfied. So this branch is nulled out. It won't work, it won't run, similar to the one when we use the jumper bit. But here I can go in and I can see that someone's deliberately done this, and there should be a note up here that says program 2 has been suspended until 2026. So somebody could go in, oh, okay, that's right, we're not using program 2. Everybody's a happy camper, know what's going on, and that's why that's simmered out. But I didn't change the logic, so later on, if I reinitiate program 2, I simply take that, hit delete, and program 2 is now back in the equation. So those are a couple of things that you can do. Another thing that you can use using not logic is if you have what they call an ambiguous state. So some large cylinders will have 2 proximity switches on either end called cylindicators. So when the cylinder goes forward, it makes the fully extended proximity switch, and it has the retracted off. When the cylinder gets retracted, the retracted turns on, and the cylinder advanced turns off. So they should always be diametrically opposed. But if on the way out it hits something solid, the air is trying to push it all the way out, but it can't, then it's neither back nor forward. And the other thing that can happen is that industry is quite abusive. One of the cylindicators gets damaged, or the wire to the cylindicators gets damaged. Now you do not have the ability to look at both states. You only have one operational cylindricator, in which case you could use, well, I'm looking for it to be forward. It's left the retracted position, and I know this because it's gone off of that proximity switch. I can't guarantee it's forward, but I know it's not returned. And that can sometimes, again, for a temporary fix, might be able to bail you out. Anyway, the one thing that I want you to take away from all this is that when you go to do any programming, avoid using blank troubleshoot or blank jumpers, because they get forgotten. You've disabled that, you're no longer controlling it, and that is the absolute key to safety and to what it is we're trying to do. We're trying to make sure that the machine behaves itself, does what it's supposed to do, and efficiently, nobody gets hurt, and we're in control of it. It's not the machine. There is no AI in one of those machines, and we like it that way.